Alright, we need to find the y-intercept for this. How do we find y-intercepts? Make x 0. So if we make x 0, this becomes 4 squared plus 1. So 16 plus 1 is 17.
Do we need to write it in there?
Yes. Alright, so for number 5, we're looking for h of g of 1. So we need to find where g is at the x value 1 first. So at 1, g is at -5. And then we need to find the h value of -5. So when x is -5, h is 0. So your answer is 0. So make sure you have that written down for 5, and make sure you have this written down for 4, and then pass up those answer sheets. Okay, that's what it is. So we worked out this triangle so that we could get these 3 values. We're going to do the same thing with this other triangle. John, do you have this? Great. So before this happened, this whole triangle, what type of triangle was that? This entire, it was an equilateral, which means what? The sides are equal and the angles are also equal. So before this happened, this was 60, this was 60, and each side was equal. So when we cut this in half, that made this 30 degrees. So could I say that C is equal to 2 times A? Yes. So just like we did last class, we are going to start off by finding the side length. So how do we find side lengths of a triangle? Pythagorean theorem. So using what we have, I'm going to say that this is now 2a instead of c. So I have a squared plus b squared equals 2a squared. So that becomes 4a squared. And I can combine my a's. And then if we're solving for b, how would we do that? take the square root of both sides, so that would leave b equals the square root of all of this. Simplifying that, the a would come out. So a times the square root of 3. We're going to come back to that. We're going to use that here in a second. Now, if we go back to thinking that this is some triangle on our unit circle, so our unit circle has a radius of 1, I can say that C is really equal to 1. So now I can solve for A. So A is now 1/2. Using that, I can also solve for B. So I can say that B is the square root of 3/2, which is correct for a 30, 60, 90 triangle. Well, now we can find the sine, cosine, tangent of these values. So what would the sine of 30 degrees be? Without using your calculator, opposite over hypotenuse, 1/2. The cosine of 30 √2. Now, when we do the tangent of 30, well, what's the x or y definition for tangent? Y over x. So that's really, or sine over cosine. So that's really 1/2, or we could have just looked at the triangle, opposite over adjacent. So 1/2 over √3/2. So we have a fraction within a fraction. What are we going to do? Multiply by the reciprocal of the denominator. So the 2's cancel and you're left with 1 over √3. Can I leave that like that? No, we need to rationalize. So √3/3 is your tangent of 30. And then we could do the same ratios, but now for 60. The sine of 60 is √3/2. The cosine of 60, 1/2. And then the tangent of 60, we have to do that fraction again, but now we have √3/2 over 1/2. So we end up multiplying by the reciprocal of the denominator again to get just √3. So you'll see that there's a table below this. And we found these values last class, so I want you to fill in the sine, cosine, tangent of 30, 60, and 45 in your table. completely, or if you know them all, you can fill them out. That's fine too. I just want to jump back up here and talk about this really fast. So we talked about this previously, but just to put it in context of where we are. So we talked about if it doesn't lie in the quadrant, it's a quadrantal angle. So if it lies on the x and y axis, that would make 0, 360, 90, 180, and 270, those quadrantal angles. So those also have ordered pairs along your circle. And because our unit circle has a radius of 1, if I'm going all the way out, this would be the ordered pair 1, 0. This would be 0, 1. This would be negative 1, 0. And this would be 0, negative 1. So in that P, X, Y column, you would put those in there. So remember that on your unit circle, because your radius is 1, when we found our x, y definitions, that's really the point cosine sine. So I can say the cosine of 0 or 360 is 1. The sine of 0 or 360 is 0. The cosine of 90 is 0. The sine of 90 is 1, and keep going through that pattern. Let's do these radians, and then we're going to do these three, and then go back and do the other ones. So we know this one is 0 to pi. What is the radian for 30 degrees? Pi over 6. For 45? Pi over 4. 60? Pi over 3. 90? Pi over 2. This is pi. What about 270? 3 pi over 2. So since these ordered pairs are x, y, and this is y, this is x, this is y over x, I can write the ordered pair of 30 degrees to be the root 3 over 2, to be root 3 over 2, comma 1/2. I can write 45 to be root 2 over 2, comma root 2 over 2. And I can write 60 to be 1/2, comma root 3 over 2. So as we talk about the unit circle, if you don't know this, we're really just going to be using these values and then changing them, but we'll talk about that in a second. So for 0, 360, since x is cosine, this would be 1, this would be 0. Since tangent is y over x or sine over cosine, this would be 0 over 1, or the tangent of 0 or the tangent of 360 is 0. For 90, your sine would be 1, cosine would be 0. When we write the tangent of 1 over 0, what would the tangent of 90 be? Underline. For 180, sine is 0, cosine is negative 1. So when writing the tangent is 0 again. And then for 3 pi over 2, sine is negative 1, cosine is 0, so that makes this undefined again. So if you don't know your unit circle, you could memorize this table of values and just use these values. We are going to talk about some other ways to know your unit circle as well. So on the next page, the triangles we found, the exact values we found, were really just for positive angles, or angles in the first quadrant. But we need to find all of our angles, all of our exact values. So we used this mnemonic. Ms. Bordelon showed me this one, a smart trick class. I used previously all students take calculus. Someone said all students taste chocolate. Whatever works for you, remember that. But what this means is, A, everything is positive here. All of your trig functions will be positive in that first quadrant. S, your sine functions, your sine functions will be positive there, as long also with your reciprocal, so cosecant. Everything else will be negative. Cosine, secant, tangent, cotangent will be negative in the second quadrant. T is for tangent, so tangent and cotangent will be positive in the third. Everything else will be negative. And then C is cosine and its reciprocal secant. Only those will be positive in the fourth. Everything else will be negative. Another way to remember these is, think about it like your XY coordinate plane. Because for your XY coordinate plane, your x's are positive over here. So that makes sense that C is x, C is positive over here. And over here your x's are negative, where C is negative. And then up here your y's are positive, so sine is positive up here. And down here, sine is negative. So you could think about it like that. However you remember that, however that helps you remember that, you need to know those. And then another way we're going to find the angles, the exact values, is by using these reference angles. So everything in the first quadrant is going to be your reference angle, reference to everything else. So depending on which quadrant you're in, depends on how we find the reference angle. So if we're in the second, we're doing 180 minus theta. Third is theta minus 180, the reference angle minus that 180. But in the fourth is 360 minus theta. So let's try this. Pick an angle in radians or degrees in the second quadrant. Anybody? 2 pi over 3. So one that's on your unit circle though. So 2 pi over 3 is 120. 180 minus 120 is 60. 60 is back in the first quadrant. And from our table, we know that 60 is 1/2 root 3 over 2. Let me write all of these really fast. So we were doing 120. So we know the reference angle is 60, but in the second quadrant, what's positive? Sine. So only the sine value of this will be positive. So 1/2 will be negative. Pick an angle in the third quadrant. That's still second. Okay, so 210 degrees. 210 minus 180 is 30 degrees. So that's back in the first. We know this is the ordered pair for 30 degrees. What's positive in the third quadrant? Tangent. So that means sine and cosine will both be negative when we write this ordered pair. Pick an angle in the fourth. One on your unit circle. 315. Sorry, I heard him first. So 315. 360 minus 315 is 45. So 45 is this. In the fourth quadrant, what's positive in the fourth quadrant? Cosine. So only cosine will be positive and sine will be negative. So we're using those same reference angles, the same values, the 30, 60, 30, 45, 60, all the way around your unit circle. Those values don't change except for some are negative, some are positive. We're going to do this in more practice. Flip to this page. We'll go back and do the other page here in a bit. Alright, so we are going to write our radians, our degrees, and our exact values all the way around this unit circle. What's the first radian? Pi over 6. Keep going. Pi over 4. Pi over 3. Pi over 2. What's the next one? 2 pi over 3. 3 pi over 4. 5 pi over 6. This is pi. 7 pi over 6. 5 pi over 4. 4 pi over 3. 3 pi over 2. 5 pi over 3. 7 pi over 4. And 11 pi over 6. Now in degrees. First degree. Keep going. Keep going. 120. I heard 1 5. 35. 150. 180. 210. 225. 240. 270. 300. 315. 330. Somewhere on this, write the letters A, S, T, C. And then I'm also going to write your reference angles. So we know this quadrant has your reference angles. In this quadrant, we're doing 180 minus whatever those reference angles are. In this quadrant, we're doing whatever the angle is minus 180. And then in this quadrant, we're doing 360 minus whatever the angle is. So now we're going to write our exact values for all of these, starting with 1, 0. What is your ordered pair for 30? Root 3 over 2, 1/2 per pi over 4. Root 2 over 2. Root 2 over 2. 4 pi over 3. 1/2 root 3 over 2. For 90, you're at 0, 1. For 2 pi over 3 or 120, that's 180 minus 120, so we're at 60. So we're going to use this, but sign is positive here, so cosine will be negative. 135, we're going to do 180 minus 135, so 45, but sign still positive. And then 180 minus 150 is 30, so if I'm looking at 30, cosine is going to be negative again. This is negative 1, 0. For 210, that's 210 minus 180, so we're looking at 30. It's going to be this ordered pair, but both are negative since only tangent is positive. For 225, 225 minus 180 is 45. So we're looking at this order pair, but both are negative. I'm sorry. For 240, 240 minus 180, we're looking at 60, except both are negative again. And then this is 0, negative 1. $300, we're doing 360 minus 300, so back at 60. We can look here, except cosine is positive. Let's see if I can write it on this side. $315, we do 360 minus 315, so 45, and cosine is positive again. I'm having the most trouble writing this on. And then 330, 360 minus 330 is 30, so looking at your 30 degrees, cosine is positive. So now let's talk about some patterns and some ways to remember this if you haven't already. So I'm going to show you this one method and then we'll talk about other ways. I'm going to attempt to draw my hand, but don't laugh because I'm not an artist at all. So that was that. Hold out your right hand and kind of tilt it to the side. Like this. And then pretend that you have some fraction in your hand that has a square root in the top and a 2 in the denominator. Pretend that that's there. You can write it on your hand if you want to. Alright? And then we're going to be counting fingers, but you need to know that each finger represents your first quadrant, so your pinky is 0. This would be pi over 6, pi over 4, pi over 3, and then pi over 2. And then anytime we count, or we're looking at something above, that's your cosine values. Anytime we're looking at something below, that's your sine values. So let's start at pinky. How many fingers are above? 4. So if you put 4 in here, we get the square root of 4, which is 2. 2 over 2 is 1. So the cosine of 0 is 1. How many fingers are below? 0. So if we put 0 in here, we get 0. So the sine of 0 degrees is 0. For your, I forgot what finger that was, the ring finger, how many fingers are above? 3. So if we put 3 in here, we get the square root of 3 over 2. So the cosine of pi over 6 is square root of 3 over 2. How many fingers are below? 1. So if we put 1 in here, we get 1/2. So the sine of pi over 6 is 1/2. For your middle finger, how many fingers are above? 2. So if we put 2 in here, we get root 2 over 2. So the cosine of pi over 4 is root 2 over 2. How many fingers are below? 2. So same thing, you get root 2 over 2. So the sine of pi over 4 is root 2. For your index finger, how many fingers are above? 1. So if you put 1 in here, you get 1/2. So the cosine of pi over 3 is 1/2. How many fingers are below? 3. So if you put 3 in here, the sine of pi over 3 is root 3 over 2. And then for your thumb, how many fingers are above? 0. So if you put 0 in here, you get 0. Cosine of pi over 2 is 0. And then below, 4. When you put 4 in here, you get 2. 2 over 2 is 1. So the sine of pi over 2 is 1. So that is one way to remember it. You just have to remember which one is above, which one is below. Otherwise, you get confused. Another way is if you're just looking at the first quadrant. So we talked about the table. You could remember that as well. Here, this goes 3, 2, 1, 3, 2, 1. Or you can count it 3, 2, 1, 1, 2, 3. 1, 2, 3, 3, 2, 1. Whichever way you remember that. And then everything is always over 2. I want to know what other patterns you see in this. Could be with the radians, the degrees, the exact values. What do you see?
Where it says, so over there, it's going to be 1 in the green, where it starts with, over there. Yeah, it's 1, 0. For the next one, 1, 2, 3, it'll always be 1 after 0. You know what I mean? You see it where it's like on the right side? Okay, so when you're determining the numerator, you always know that it's over 2, but here it's 0, so you'll start at 1, then you'll go 2 to 3, and when it starts out 1, you'll start at 3, 2, 1, and then here works the same way, it's 0, and if you go the other way, it'll be, it'll be 1, 2, 3, you know what I mean?
So counting from 0 to 3 and vice versa. What other patterns do we see?
In the groups of 3, like 30, 40, 30, 45, 60, it always goes up by 15, but then jumps 30.
Okay, so let's not do red because we did that already. So here you're saying it adds 15 and then it jumps 30. Did that here too. So each is 30, 15, 15, 30, 30, 15, 15, 30, all the way around for your degrees. Any others? Because there are a bunch. Maybe look at the radians. Do we have patterns there?
It's always like 3.6.
Yes. And 2 for for those. So 3, 4, and 6 is always your denominator unless you're on a quadrantal angle, then it's 2 or 1. Anything else?
Did you have something else?
I have a list.
Could you send that list to Eduardo or something?
I will. I just want to see what other things you guys come up with. Even if you think it's minor, say it. Preach.
When there's a 3 on the bottom, it's just like 2 pi over 6. It's like doing 6, 4, 6, 6, 4, 6.
Okay, so you could think about all your 3s as really 6s, and then it'd be 6, 4, 6, but you reduce. We did the counting method, so you could count your radians by pi over 6s, by pi over 4s. You could even count them by pi over 3s and pi over 2s. So this is 1 pi over 3, 2 pi over 3, so that means we're counting by 60s. 3 pi over 3, 4 pi over 3, 5 pi over 3, 6 pi over 3. In 2s, it'd be 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. And then in pi's, it'd just be pi, 2 pi. Any others?
For the radian, the denominator is always the same as this one across from this.
So, like here. So like these
Oh, I meant like down.
down
Like
across vertically. Got it.
no, like there's the lines that follow the angles, like these are
So diagonally across.
yeah. Yeah, like that.
So those denominators are the same. I'm going to take a second and pause. What else are the same for those 4?
They're by 5 for like the angles.
The
Like divisible by
okay, but not in that sense. Like about your exact values.
They're all 3 for 3.
They're all
Two.
root 3 over 2, 1/2. The sign's just changing. Because really, we found that original triangle, and all we're really doing is flipping it. So when we flipped it here, our x became negative. When we flipped it here, both became negative. When we flipped it here, our y was negative. Same thing for the others. This is going to become really messy really fast. I didn't do what I wanted it to do. That's okay. So when we're looking at this triangle, which happened to be part of the same one, we're looking at that 30, 60, 90, but here it's just flipped. Here it's just flipped. Here it's just flipped. And then the same thing for your 45s. So we can say at each 45 they're going to have the same exact values, just the signs are going to change. At each 30, it's going to have the same values, just the sign's going to change. And at each 60, it's going to have the same values, the signs are just going to change. What other things did they say? So these are some interesting patterns that some of my students found last year. So if you're looking at your radians, in quadrant 1, all of the radians have 1 pi over your denominators. In the second quadrant, all of your radians are 1 more in your denominator than your numerator. In your third quadrant, your numerator is 1 digit more than your denominator. And then in the fourth quadrant, your numerator, they said something weird. They found a pattern.
It's 1 away.
2 times more and subtract 1 over that.
It's also like 1 away from 2. It's like 5 pi over 6 is 1 from 6 pi over 3. And then like 8 pi over 4 and 12 pi over 6.
So if you multiply by 2, subtract 1, you get those. And then really just same types of things. We see that these are the same vertically as well as horizontally and diagonally. Just whatever it is changes. So if it was positive up here, it's negative down here. If it was positive over here, it's negative over here because of our xy plane. Let's do this again. No, just... Okay, it was the recording. That's what was coming up. Alright, let's do a few of these and then we'll be done for today. So, these are asking about the signs. So, remember, a smart trick class. For these, I'm a visual person, so I draw this out, except for the ones with just one. So, if this means tangent is positive, which quadrants would the terminal side lie? So that just means where could tangent be positive? 1 and 3. So if you need to, go back and draw it. So for 2, that just means where is secant negative? That means where is cosine negative? So where would this be negative? 2. Not in 4, less than 2 and 3. Where would sine be positive? 1 and 2. But now when they have 2, you have to apply both. So this is where the visual part kind of comes in. So look at the first piece. Where is cosine negative? 2 and 3. Of those 2, where could cotangent be positive? Of these 2. Just 3. So these should only have one answer. Because you're doing what applies here, and then from that, what applies to the second one. Unless you guys do those 2. For these, now if you know these already, you can put them down. But if you don't, kind of use your reference angle, use your, what we were talking about before. So let me find one that would actually apply. So like number 2. 5 pi over 3 would be in which quadrant?
2. 4.
4, because it's 2 more, subtract 1 is be in the fourth. So because it's in the fourth, that means it's going to be positive or negative? Negative. Now, we could relate this to something in the first. Tangent of pi over 3 is what? You may need to look back at your table. So simplified was just root 3. So that means tangent of 5 pi over 3 will just be negative root 3. Now you could do this with these values as well, your cosine and sine. But if you know them, you don't need to do this. 11 pi over 6 is in which quadrant? 4. Is cosine positive or negative there? Positive. What is cosine of just a pi over 6? Positive root 3 over 2. So cosine of 11 pi over 6 is just going to be positive root 3 over 2. So if that helps you see it, see where it would lie, see if it's positive, negative, and then find it, do that. But if you know cosine of 11 pi is root 3 over 2, put that. You don't need to do all of that if you know it. Now, I do want to do a couple of the reciprocals. So just remember that your reciprocals are just that, reciprocals of whatever the original value was. So for cotangent, what is the tangent? Let's say this. What's the tangent of pi over 4 first? You may need to look back at your table. 1. 7 pi over 4 is going to be in which quadrant? 4th, which we know tangent is negative there. So if you flip 1, it's still 1, it's just going to be negative. So cotangent of 7 pi, so that was a bad example, sorry. I wanted one where it actually flips. This one's a good example, number 8. So again, we know that's in quadrant 4. Cosecant is negative there because sine is negative there. What's the sine of pi over 4? Square root of 2 over 2. So remember when we found that value from the triangle, it was originally 1 over the square root of 2, but we rationalized it. So if you think back to it was this, that means in reverse it's going to be, or cosecant is going to be this, but negative. Or you could flip this and then rationalize it again. Both ways would work. It's just, if you remember doing it from the triangle, we had 1 over the square root of 2. So you don't need to go back and do all of that work, but you can. But the cosecant of 7 pi over 4 would be negative root 2, because it's in the 4th quadrant. So the reciprocals have a little bit more work because you have to flip, but same process. I want you to go ahead and do these two and the remaining ones in here. Be careful with your negative angles. Remember, it's just whatever it would be in the positive, but you're going in the negative direction. So think about where that angle would be in the negative direction.
You guys can work together.